There are a lot of questions around what SCRs are. That's a silicon controlled rectifier, not silicone. This gets I used to do it too, but it's silicon, two different things. And how does that play a part in a chiller system? And what do we do with it? How do we troubleshoot it? So we're going to talk about that today, and I want to take it from a very layman's perspective. You Google search, SCRs and stuff, and we use them in all kinds of places. And I'll talk about the two main types that we apply them from a chiller perspective. But Google searching, you'll get these fairly in-depth, somewhat complicated, and usually applications that don't really have any pertaining to us and that we can directly apply. Sure, you'll see some fancy, maybe graphics of what the electrical internal symbols look like. But let's actually break that down to a basic technician level. What do I actually need to know about this thing to be able to work around it, troubleshoot it, move forward? How you doing? I'm Holden Schamberger. I'm with HVAC Time and Chiller Academy, specialized in chiller systems. We're going to talk about it today with SCRs. So let's start with, where do we use these? There's two main areas that they get used. It is in a soft starter or a VFD or VSD, whatever brand you're working with, AFD if you're dealing with a train. Either way, those are the two main applications where you'll come across SCRs in the chiller world. Now, you also see them if you're working on outside of chillers. Let's say you've got a fan power box or something. They may use them to control the heater or something to that effect, right? We can do a variable heat control and da 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 da. Let's keep this in the chiller world. So starting off, the simpler one would be a soft starter. So a soft starter, what we'll have, it'll be a regular starter contact, but we'll have a set of SCRs attached to the side of it. And what a silicon controlled rectifier does, with a VFD, we use it slightly differently, but I'll get into that in a second. So essentially, it's got internal gates, and those gates act as like switches or relays. Now, all this is solid state. That means that there's no physical movement of mechanical parts internally. It is the transition of the PNP electrons, or whatever the proper terminology is inside of there. As we're shifting the silicon from an electrical standpoint, we can make it flow or not flow a particular way. So we also have a set of gates that act as activators. They're basically the coil, if you will. So these will be little small pins that plug into two little pins sticking out of the SCR, and then you'll typically have three terminals on the SCR itself, where it'll be your collector, you'll have an emitter, and then you'll have a what is it, a base, or either way, you'll have 3 points. One will be power in, the other will basically be power out, the other two. So what we can do with that is we want to gently start the motor. And if we just pull the contacts directly in, well, that's a lot of starting current. These SCRs have the ability to open and close very quickly, but we can do it in such a way to where we just momentarily give that motor bumps. So we're talking about the compressor of the chiller. We're going to momentarily give it bumps, and every time it closes, we close it for just a little bit longer each time, the internal gates. So as the gates are closing and the switch is staying closed longer and longer, the motor is gaining speed, and we're very gradually able to bring the motor up to speed before we just bring the contacts in to then hit it with power, and we have a much, much lower RLA for startup. Now, for a soft starter, the SCRs will only be in effect for just moments. It's just mere seconds that it's doing that to start bringing the compressor up before the contacts come in. So it's not very long, and they generate a ton of heat in the process. It's why it is important that they're mounted and they've got thermal paste and they're done correctly so that they can dissipate the heat that they generate. And once the soft starter transitions, the SCRs just get pulled from the equation. They're no longer being used, so they'll be put into an open state, and we'll just go through the contacts from there. That's all we got to do. Now, if you hear the term solid state starter, these are also talking about an SCR type device. And a solid state starter, essentially, instead of having the contacts, it has even bigger SCRs. Granted, they require a lot of extra cooling, but it'll be the same thing, except when the transition would happen that we would pull the contacts in, those those SCRs would just get locked into a closed state, and they are the starter. They are the contacts at that point, and they're just doing a direct pass through. So that would be a solid state starter versus a soft starter. Both are using SCR type technology to gently bring the motor up to speed and then give it full power to let it ramp up and do what it's got to do. So on the other side of that, when we're applying it to a VFD, we're using it as a proper rectifier. So the rectifier is when we're removing part of the sine wave out of AC current. So as you come into your VFD, one of the first components that power will hit is your SCR bank. And typically each leg of power will have its own. And we're going to pass through that SCR in order to remove or rectify part of the sine wave. Now, typically we do this but via a what's known as a half wave rectification. Point is, it's removing part of the sine wave intentionally, which is where that third gate comes in, and we're able to convert it to a impure DC current coming out of the SCR, even though we were AC coming in. And that is what the SCR's job is to do at that stage, and it will be triggering the gates to basically be a power pass through, but filtering the sine wave. Instead of like with a starter, we're using it to slowly ramp a motor. Well, in this particular case, we're using it as a filter. And if you're curious how VFDs work or how we're doing it from the chiller side, I've done a whole video talking about the power pass through, and I've talked about IGBTs. So I'd encourage you to go back, find some of those videos, and catch up on it from that angle. I'm not going to dive into that again today. We're going to stay focused on just how we're using the SCR. So those are your two main functions. That is how we're applying them to the chiller world, either as a filter or as a part of a starting component to bring the motor up to speed. How do we test that? So this is where you'll want a meter that's got a really good diode test to it. So a diode test, let me show you. A diode test is going to be down here at the very bottom. A lot of times it'll be tied into continuity. You see it there. A lot of times it'll be tied into the continuity test feature as well. So you don't have to worry about the continuity side of it. But what'll happen is this meter will generate a voltage value, a DC voltage. So if I use my little test I got here, we'll put that there. Maybe you can see that. If I go from one side to the other with my leads, I get a voltage of 0.35. And if I flip my leads around, I get an OL. That's a good test. So what that test is doing is we're checking how the gates are internally. So these gates are single direction. They only allow pass through of voltage one way or the other. So when we're doing a continuity check, our positive and negative leads are actually outputting a positive or negative DC voltage, and that is being caught by the gates, which are not activated right now. So with it turned off, it's acting like a check valve. Anyway, without getting too deep into the weeds, you'd go from terminal number 1 to terminal number 2 and number 3, and you would test those, and depending on positive to negative lead configuration, you'd either get a decimal voltage value. It's a DC voltage. That value will tell you what condition that gate is in. So me getting a 0.35 on this shows a clean or a pass test. I would say that that gate is doing exactly what it's supposed to. And then I can flip my leads. I get an OL. That's good. That's what it's supposed to do. You'll also have the two little small terminals, and typically I'll check resistance through those. And again, it'll depend on the SCR itself on what that resistance is supposed to be. But that is showing your actual, basically the coil, if you will. It's not a literal coil. Don't mistake that. I'm using the coil term, like a relay coil, just to communicate what its function is, how it's being used, even though it's not a literal coil. So just be cautious with that. And I don't even have a value I could give you for that. Maybe somebody in the comments here will be able to provide maybe some general values those may be. For me, usually if I'm working on a system, some of them may give me a value that those 2 points are supposed to read, the service manuals. But if I'm working in a system, a lot of times there'll be at least 3. Because everything's typically 3-phase for me. So there'll be at least 3 in there. And usually I can check across all 3 and then compare the numbers and see which one is just dramatically just not even in the ballpark. So then I can address that one that kind of was the standout, if you will. So from a test function procedure, and I can do a more in-depth, this is how you troubleshoot video later, where I actually get one on the table, and I'll do also one for that IGBT, sit down and I'll take you through kind of that physical test, let you see it. But for today, that is the general concept of how we would test that, and that's with nothing else connected to it. You know, you can't have any leads, nothing else, nothing has to be plugged in. So you don't want you don't want the test to be influenced by something else. But that's your basic SCR. That's how we use it. That's how we do some troubleshooting with it. And when I've had them fail, typically they'll do some kind of overcurrent. Then they'll fail one of 2 ways. Either they'll fail, and like say with a soft starter, had one call where it was showing a phase loss at startup. Once because one of the SCRs had failed and it wasn't passing power through properly. It may show an overcurrent, so or a phase imbalance. So maybe it can close, but it's not opening properly. So the others are working and they're trying to bring it up slowly, but this one just slams shut. That's going to cause an overcurrent or an imbalance in the current. Or my favorite, they just blow up. Genuinely, SCRs, when they fail, they just grenade into 1,000 pieces, and you just don't want to be there when it happens. So that's one of the dangers of working with that level of equipment. It is very dangerous to touch, be around, be cautious, think about those things. With that, if this has been really helpful for you, please go check out chilleracademy.com. I've got some courses on there for you that can help you come up as a chiller technician. It's a lot of the same stuff I needed when I started and just didn't have. So I made it so that somebody could have it and that it existed. With that, MTT, make the time for your family, for your spouse, for your kids. They really need you around. Thank you.